All right, welcome to the review. This one's going to be a little bit faster than normal, but I'm going to do at least 2 problems from every section so that you can see what's going on. The test is tomorrow, Tuesday, January 24th, or Wednesday, January 25th, if you are a B-Day student. So here we go, good luck. Number 1, the parent function is y equals x cubed. So if I'm writing the equation, I'm just kidding. Something's going to go there if there's a stretch. Something would go there if it has a left or right movement. I put a cube because that's the parent function. And then something could go there if it's been shifted up or down. By the way, on number 2, that was a typo. So the parent function is y equals x cubed. It is reflected about the x-axis, so I'm going to put a negative right here because it was reflected. A vertical compression by a factor of 0.5. Stretch your compressions, go there. A translation of 7 units up. If it's going up or down, it's on the outside. And a horizontal translation of 2 units to the left. So to the left is this way, so we have to go the opposite. Anytime it's left or right, it's the opposite. I'm going to put a +2 because that's the opposite of negative. So my final answer would be y equals negative 0.5 x plus 2 cubed plus 7. Okay, let's look at one that's a square root. On the square root graph, there could be a stretch. There could be a right-left movement here. There could be an up-down movement here. So a vertical stretch by a factor of 2. Where does that go? Vertical stretch, a reflection across the x-axis. It's reflected, it goes out front. A vertical translation 2 units. So vertical is up and down, which means it did not move left or right. So my final answer was this one. Y equals negative 2 times the square root of x plus 2. Problems 3 and 4 are just like it, so let's jump to problems 5 and 6. On problem 5 and 6, write the equation of the function just given the graph. You have to recognize what the parent function looks like. This one where it's going up like this is an x cubed graph. On number 6, where it's just part of that parabola, this is a square root x graph. That's the parent function. So on number 5, it starts here. Again, kind of the basic skeleton looks like this. If it starts with the origin 0, 0, we're going to put zeros in here because it's not moving up or down. But what's the stretch? What's the general pattern for a cube? Over 1, up 1, over 2, up 8.
Teachers, if you could please leave an email, that would be
Now, when I'm looking at the stretch, I went over 1, up. It looks like 1/2. So we're thinking that this probably has been multiplied by 1/2. But to confirm, if it has been multiplied by 1/2, I should be able to go over 2 and up 4, which it did. So the compression is 1/2, which means my final answer, y equals 1/2 times x cubed, and that's it. All right, number 6. This is a square root. Again, the basic skeleton will look like this. There could be a number. There could be a number. There could be a number. Now, it's all these 2 numbers indicate the starting point. So I'm going to go left 2 and up 1. To indicate the left 2, on my equation, left 2, up 1. So those will cancel, make it positive. Now let's look at the stretch. So the stretch on this one is the flip of my parabola. So instead of over 1, up 1, I'm going to go up 1. over 1 up to over 4. We switch the x and y's because they're inverse function. Remember, on the inverse function, you can switch the x and y's. Does it go up 1 over 1? Does it fit that general pattern? Does it go up 2 over 4? Yes, because it does that. My a is a 1. So my final equation, y equals the square root of x plus 2 plus 1. Next page. Let's do just a couple more. I'll do 7 and 8. This one, again, is part of a parabola. So y equals, there could be something, square root, x minus could be something, plus something. This right here is my starting point. It didn't go left or right, but it went down 7. Now we look for the stretch. We expect it to go up 1 over 1, right? Now, depending on how high it went up, that's going to multiply my ups, and that will be the a. So it went up 3 over 1, which means a equals 3. Final equation, y equals 3 times the square root of x minus 7. Ow. All right, number 8. This is the cube root graph. So those are the 3 holes we need to fill. This is the starting point. I know it's a cube root because it looks like a cube, but flipped on its side. The general pattern for a cube root is up 1 over 1, up 2 over 8. If 2 cubed is 8, or the cube root of 8 is 2. Either way. It did not have any left or right movement, so again this is 0, but it went up 3. Now let's look at the stretch. I expect it to go up 1 over 1, but again, if it goes up more than 1, then before it goes over 1, then that up has been changed. So it went up 1 over 1, and a is 1, which means my equation y equals the cube root of x plus 3. All right, next one. State the domain and range of each function and sketch the graph of the function. So I will do a couple of these. Let's jump to number 10. This is a cube root, or a cube function, which means it looks like this. The pattern looks like this. My starting spot will come from this number and this number. We do the opposite of -1, and then we go down 2. Now, because my a is 2, I'm going to take all of the ups and double them. So to get to my next point, I'm going to go over 1 up 2, and then over 1 down 2. So far I went over 2. Over 1 down 2. And then the next one is over 2 up 16, which gets us way off the grid. And then over 2 down 16, way off the grid. So you just want to make sure that you don't pass this line as you're coming down. And like that. It's very vertical. All right. Let me just check really quick. Is there another one? All right, let's go back and do number 9, simply because number 9 has a negative in front. So we're using the same pattern. We may not need the multiply 2. I don't know if I can erase this without erasing the whole thing. Hold on. Okay, so this one doesn't have any left-right movement, but it has been shifted down 2. So there's my starting spot. Now the general pattern is right here. But because of the negative, I'm going to make all of these negative. So on the right, instead of going over 1 up, I'm going to go over 1 down. And then on the left, I will go up. So it just shifts directions. And then over 2 down 8, which will get me off the graph about right here. Over 2 up 8, right here. And the graph should be going down as time goes on because of the negative, and it is. All right, next one, let's do one of each of the other types of functions. There's another cube, so let's do the cube root. The pattern on the cube root is the opposite of the cube function because they're inverses. There has been no left-right movement or up-down movement, so it's going to start at the origin. But the a is 3, so that means I'm going to take all of my a values and triple it, multiply it by 3. So instead of going up 1 over 1, I'm going to go up 3 over 1. Still just 1. We're not going to multiply that by 3. And then instead of up 2 over 8, I'm going to go up 6 over 8. You have to do it in both directions, down 3 over 1, down 6 over 8. And then you connect them. Like so-ish. It's kind of wobbly, but it looks like that. Next page. Let's do a square root function now, number 14. And the pattern for a square root is up 1 over 1, up 2 over 4. The starting spot has been shifted right 4. And the a value is 2. So graphing is I like it because it uses the same pattern over and over again. I can take the cube graph and the square root graph, which don't have a lot in common, but use the same sort of rules. I use different patterns because of the different functions, but the two means the same thing no matter where it's at. If it's a cube root or a square root or a x squared, the minus 4 inside of the x will mean shifting it right 4, regardless of the parent function. So that's kind of nice. All right, instead of going up 1 over 1, I'm going to go up 2 over 1, and then up 4 over 4. And it should look like an arc. Now when I grade this, I'm looking for the individual points. So please make sure they're there. All right, moving on. Now let's do a couple piecewise functions. Okay, on the piecewise function, you have to start by looking at the domain that the function, I want you to graph the function. So I'm just going to use a lighter color. This first function needs to be between this line and this line. You could just use a pencil and draw the area, but it needs to be graphed. You could use a Post-it to section it off, or you could just see it and figure it out. Now you have to look at the parent graph. On this one, it's the absolute value, which looks like this, right? The plus one is the same thing as the other graphs. It starts right here. And then the absolute value, the slope is 1. So I'm going to go up 1 and over 1, up 1 and over 1. Now when I hit this end right here, it does not have an or equals to. So on this end, I have to put an open dot. On the other end, it does have an or equals to, so I'm going to put a closed dot. Looks like that. Now for the next piece of my function, it's going to be between 2 and 7. There. This also is an absolute value. It has been shifted right 3. So here's my axis, right 3. So my starting spot's right here. And then the a is negative, so instead of opening up, it's going to open down. So it'll look like this. Open dot at the 7, closed dot here. And that's what that one will look like. Okay, number 18. This one breaks off the domain into 3 different pieces. The first one is less than 1. This is an x squared graph. The minus 1 is a shift down. The pattern for an x squared looks like this. The 2 means I'm going to multiply all of my ups by 2. So, over 1 up 2. Now on the 1, it does not say or equal to, so I'm going to put an open dot. But on the left, I can close it. and then over 2 up 8. We'll land it right here. I need to hurry, the power's going to go out too. Okay. Then, between 1 and 4, so this section I'm going to have a closed dot on this end and an open dot on this end, right? Because closed dot, open dot. Now in this one, my function is always -2. It doesn't matter what the x is, the y is always -2. So it's going to start right here at -2, and the slope is 0, the slope is 0, so it's flat. So that's what it looks like. If there's an x value with it, then it's a line, but without the x, it's still a line, it's just a flat line. Alright, the next part of the domain is x is greater than 4. It is not or equal to, so it's still your open dot. The square root graph, the pattern is the reverse of the one just above where I'm writing. We switch the x's and the y's, right? Okay, on this one, it's going to be a little bit different. So, it starts at 0, 0. Now, what I'm putting on there isn't actually a point. We're going to have to go back and erase it, or just ignore it. A is negative, so I'm going to multiply all those by a negative. So I'm going to go down 1 over 1. Still, that's not part of my graph. I'm going to go down 2 over 4. Still not part of my graph. I'm going to go down 3 over 9. That's where my graph happens. So the yellow dots in there are kind of like placeholders. Something like that. They're like placeholders. So that I can put my grid on there. Because the starting spot for the x squared is not actually in the domain that I'm graphing. Okay, let's look at one more and then we'll move on to the step functions. I'd like to try number 19. The first one, the domain is everything less than 2. And the function is just x. X is a line. The starting spot is 0, 0. And then up 1 over 1, up 1 over 1. Right here, it's an open dot. And then go the opposite direction. The more dots you put on there, the more accurate your grid is. Something like that. Okay, the next function is between 2 and 4. Again, I kind of have to just picture what's going on. I'm starting down here at -4. My pattern, over 1, up 1, over 2, up 4, but I'm going to half all of those. So over 1, up half, over 2, up 2, and that should be a close dot. And now we're in the section of domain that I want. Over 3, up 9, but I'm going to half 9. So over 3, up 4.5. And then it would be over 4, up 16. But half of 16 is 8. So over 4, up 8 gets me right here. Open dot right there. So if I were to connect those, it would look something like that. That's a weird graph, but that's what it would look like. Okay, moving on, step function. The step function always rounds the number down. So the parent graph starts right here and goes like this. Oh, goes like this. Whatever. But it starts from 0 to 1 on the 0 line because it's rounding it down. Now this +2 is going to shift that up 2. And this times 2 is going to mean that in between steps I have to jump 2. So my first one has been shifted up 2 from here to here. Now to get to my next one I have to jump up 2. So from here to here. Open dot on the end. And then jump up 2. Jump up 2. And then go down. All right, Now this minus 1 plus 1, it's interesting, the minus 1 plus 1, this will move it right 2, and this will move it up, or sorry, right 1 and up 1. So if my parent graph was here, my starting spot would move to the right 1 and then up 1. So this is where I would start. And then, because I haven't stretched it at all, right, I'm not jumping, it just looks like this. Interesting enough, this looks like the parent graph. So that minus 1 plus 1 on the step function cancels each other out, but it doesn't on any other function. So anyway, this minus 1 plus 1 canceled each other out, and this actually is the step function. Next page. When the 0.5 is inside the step function, it's going to make the step function go longer. When it's on the outside, it means the jump is half as big. So my starting spot would be at minus 8, and that would be my first one, and then it's going to be a half step jump. Kind of like these have circles on the end. Hard to do with my board. So that's what this one would look like. But if the 0.5 was inside, it would make those steps go longer. The 3 is on the inside, but it doesn't affect it the same way as a decimal would. On the 3, it actually doesn't. I'm skipping that one. I think it actually is going to make it go shorter. Because if I plug in 0.3, if I plug in 0.4, it means 1.2, that would jump it to a 1. So I think I taught that to you wrong. Looks like this isn't on the test. I think it should look like this. So it should take 3 integers before it gets to 1. Yeah, I taught it to you wrong. Told you I've never taught this before. So it's going to be the third of the length. And it looks like that. Very small. Okay, moving on. Now, I hope that you're okay with this section. Find f of negative 5. Well, negative 5 fits in this domain. So if I plug in negative 5, 5 squared is 25, times 3 is 75, plus 2 is 77. Find f of negative 1. Well, negative 1, erase this to be sure, negative 1 does not fit in this domain, and it does not fit in that domain, so I'm going to put no solution. F of 4 fits in this one. The square root of 4 is 2, minus 5 is negative 3. F of 7 fits in the lower one. The absolute value of 7 is 7. Okay, number 28. Find the inverse of each function. Determine whether the inverse is a function. So to find the inverse, you need to switch, this is normally a y, so switch the x and the y and solve for y. So the first thing we'll do is add 9. And then we'll divide by 5. And then you take the square root. And anytime you are putting the square root on, a plus or minus needs to go on. So y equals plus or minus the square root of x plus 9 over 5. And then determine if it's if the inverse is a function. And this inverse, because of the plus or minus square root, will look like this. That does not pass the vertical line test, so no, it is not a function. This is the only situation where it would not be a function. Every other time is a function with the equations that you're dealing with. So on the next one, this is y, so switch it to an x and switch that to a y. Then you're going to subtract the 1, divide by 3. So this is just a line. So yes, it's a function. On 31, if I switch that, this is now my x, this is my y. Let's multiply by 2 first. So I've got 2x equals y squared plus 1. Subtract the 1. Take the square root. Again, plus or minus, those cancel. So now on all of these, instead of saying y equals, I should have said f prime of x, so please switch those. Plus or minus square root 2x minus 1. Again, because it's plus or minus square root, it's going to look like this, which does not pass the vertical line test, so no, it's not a function. Okay, next page. Domain range, domain range. Now this one is just a line. I could graph it plus 1, and then to get to my next point, I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, and so on. And then up 2 over 1, because that's my slope. Because it's a line, it goes forever in both directions, so the domain is going to be all real numbers, and the range is all real numbers, which means the domain of its inverse is the same as the, remember those two are the same and these two are the same? All real numbers. Graph the function and its inverse. Okay, so now we need to graph it. The function, if you do an xy table, I have the points 0, 1, negative 1, 3, negative 2, 5. Now if I'm doing my function inverse, let's just switch the x's and the y's. So 1, 0, 3, negative 1, 5, negative 2. So 1, 0, 3, negative 1. Is that right? That's not 3. That's why it looks funny. 3, negative 1, 5, negative 2. And from there I should be able to see the pattern to keep putting my points on the graph. If it's a line, it's pretty easy. If it's not a line, maybe you should write more points down originally so you can flip them. Okay, let's do the next one. F of x equals negative x squared plus 1. Well, the plus 1 shifts the graph right here. The negative x flips the pattern down, so over 1 down 1. Over 2 down 4. Over 3 down 9. So something like that. The domain, again, are all possible xy numbers. So this is all real numbers, which means the range of my next one should be all real numbers. The range, however, is everything from here down. So how do I say that? From negative infinity, and it tops out at 1. 1 needs a bracket because it's included in the range. It goes all the way up to 1, not past. Which means my domain here is from negative infinity to 1. Let's confirm with our picture that that's actually the case. Let's do an xy table right here. I feel like I'm racing the clock. There was an accident on Redwood, and we know that the power's going to go out soon. We just don't know when, and if the power goes out while I'm recording, I lose all of this, and I'm not doing it again, so hopefully you are hearing this because I beat the clock. Okay, the points are negative 2, negative 3, negative 1, 0, 0, 1, 1, 0, and then 2, negative 3. So that when we flip-flop those, if you can just see it without rewriting it, then go for it. I always make a mistake when I try to do something like that. So I would rather just write it down so I don't screw up. So I've tried to not write it down before, and then it just takes me more time to figure out what I did wrong. 0, 1, 1, 0. And then I didn't write these bottom 2 points down, but if I did, they would be right here because it follows the same pattern. Just like that. That was a really good one. All right. Any of the last questions? Yeah. Okay. Let's do one more. Let's do number 35. So this is a square root graph. The starting point it's a little bit different than the ones we've done before because the 2 is inside the radical. So if I were doing an xy table of this one, what are some pretty numbers I could plug in for x to make this a perfect square? So 0 would be a perfect square. 1 would not though, because 1 times 2 is 2. 2 is not a perfect square. So maybe 0.5 would give me a perfect square, right? Because it's half of 1. And so 2 times 0.5 would be 1. And then the next perfect square is 4. So if I plugged in a 2, I would get a 4. And then the next perfect square is 9. So 4.5 times 2 is 9. Now if I plug in 0, I get 0. If I plug in 0.5, I get 2 times half is 1, square root of 1 is 1. If I plug in 2, I get a 4, square root of 4 is 2. And if I plug in the 4.5 times 2 is 9, the square root of 9 is 3. So these are my first points, 0, 0, 0.51, 2, 2, 4.53, and it looks something like this. The domain range for this one is a little bit different. The domain is all of my numbers from here over, right? So from 0 to infinity, which means my range is from 0 to infinity of the next one. The range is from here up, so from 0 to infinity, 0 to infinity. Okay, so let's plot the next set of points. X, Y, let's put down 0, 1, 2, 3, 0, 0.5, 2, 4.5. 0, 0, 1.5, 2, 2, 3, 4.5, and then if it was 4, I'd go all the way up to 8. So now this is a parabola. Because the original function had a domain restriction, the inverse function has a domain restriction, so you're only getting the 1/2 of the parabola, which is interesting. Okay, that's it. Hopefully I answered all your questions. I did miss a little bit. Hold on before I go. If you can tell me on the test why I was in such a hurry to get this done, why I was racing the clock, you can get a point extra credit. So thanks for watching. Good luck on the test tomorrow or Wednesday, depending on when you have it. Peace out. See you later.